What does collecting better data mean, and how do we achieve it? So here is the agenda for today. We're going to start by thinking about evidence-based decision making. I'm going to highlight the difference between better data and good enough, and the link between better data and errors. And then we're going to dive into something that we're borrowing from the academic world, total survey error, which is going to show us how to create a framework to identify where we need better data and how we should set about getting that better data. And we're going to look at it in two ways. One is we're going to map problems to solutions, but we're also going to map solutions to problems. So the growth of data, we hear about it all the time. There is more and more data. And one of the fantastic things that is happening is we are seeing a rise in evidence-based decision making, partly because there is more data. And also this wonderful quote from a long time ago, without data, you're just another person with an opinion. So we want to make sure that we have the right data to help us make better decisions. And we don't always need to improve things. There are lots of things around which are already good enough. A knife, a fork and a spoon for most Western people is good enough. We don't need another alternative. Occasionally we see people coming out with new alternatives. So a fork and a spoon or a knife and a fork built into one, they don't take off. The bed, yeah, there are water beds, there are hammocks, there are futons, but pretty much the bed does a good job. The Sharpie, wonderful job. Post-its, you would have thought they would have gone digital. Of course, there are digital things, but go into any office and you'll see Post-its everywhere because they're good enough for the job. Steps, good enough for many jobs. So don't think that everything has to be better. Lots and lots of the things that we're using at the moment are good enough. The next thing is we need to prioritize. So if we look at this wagon here and we think of it as a mode of transport, that front left wheel isn't great, but fixing it will not improve this vehicle. Fixing the canvas over the top will not improve this wagon as a mode of transport. That back wheel on the left-hand side and the missing wheel on the right-hand side, they have to be improved. No amount of improvement to the least bad items is going to improve the total outcome. So we really need to identify what urgently needs to be fixed. And I'm going to show you that in an algorithmic form here. Imagine that we have a data collection process, we have something to do with surveys and marketing and trying to find out which product to use. There are 3 steps in our data collection, A, B and C. A has got an error of plus or minus 10%. B has got an error of plus or minus 20%. And C has got an error of plus or minus 50%. It's really, really flaky C. So our confidence, when we use all this information together, we're 90% confident about A, we're 80% confident about B, we're 50% confident with C, we end up with an overall confidence of about 36%. Pretty poor. Now imagine somebody comes to us, a vendor, and they say, I can reduce your error in A by half. Well, superficially that sounds attractive, but let's plug the numbers in. Now we're 95% confident about A, 80% confident about B, still only 50% confident about C. So we have improved our confidence from 36% to 38%. Pitiful, really. Now another vendor comes along and says, I can reduce the error in C by half. So now we're 90% confident in A, 80% in B, 75% in C. And now all of a sudden our confidence jumps up to 54%. It's better than tossing a coin now. That is the difference by attacking the places where the error is biggest and not tackling the places where the error is smallest. So this is the academic concept I talked about before, total survey error. And it's talked about a lot in academic circles, and it's a fantastic tool. And we're going to explore it in a practical sense. How can it help us? And we're going to do that thinking about TSE, total survey error, in the context of the USA presidential elections in 2016, where they were shockingly inaccurate, and 2020, where they weren't great. And we'll think about what happens. So the typical model for prediction election is we ask people who they say they're going to vote for. We try to work out how likely are they going to vote, and then we're going to weight by demographics and the way they voted last time to try to represent the country to make a prediction. So the first thing we have to consider in this framework is validity. Are we asking a question that works for collecting a prediction? Is asking people to say which way they're going to vote a valid way of predicting the results? And although lots of people are very doubtful, it turns out it is reasonably good for predicting which way people vote at elections. But if I were to ask you to predict what you will eat on Saturday, what's the chance that it will be right? It's got quite a big error term, even though you might be fairly sure at the moment. Things happen, you feel like something different, it can change. Is waiting by a previous election going to work if we have an atypical campaign? President Trump wasn't like previous Republican candidates. So trying to look back on that information is going to produce a less valid result. Measurement error. Did people make a mistake when they were entering their answers? This is something we always need to be careful of. Is the scale capable of collecting the data accurately enough? So when we're trying to say how likely you are to vote, is the sensitivity right? Can people give us a good number for that purpose? Did the survey correctly display on their device? So if the survey was on a mobile, could they see all of the options? If it was by voice, did they hear all of the options? Did it capture everything that it should have captured? So all of those would fall under measurement error. What about processing error? So did we spot all the bogus or flawed responses? Was the likely voter adjustment correct? Did we weight the data properly? All of those are things that could result in the wrong answer. What about coverage error? Coverage is where we define the population we're trying to reflect. So we then want a sample frame that reflects the right groups of people. In this case, the population is people who vote. The population isn't everybody in the United States. You have to be registered to vote, and then you have to be one of the people who does vote. That's a much smaller group. Online surveys reflect the people who are on the internet. That's going to miss some people who vote. There are plenty of people who vote who are not using the internet. Panel surveys reflect people who've signed up to panels. Most people, maybe 98% of the population, don't sign up to panels. So is it a good match? Telephone surveys reflect people with a phone who answer it. Yes, lots of people have got phones. Nearly everybody's got phones. But not nearly everybody answers the phone to calls from people they don't know. Then we get to sampling error, and this is the one that market researchers always seem to talk about. What is the risk that just by bad luck we have a sample that doesn't reflect the population? This is why you'll see people collecting a sample of 1,000 people and saying that the error is plus or minus 3%. Actually, they mean that if it's a random probability sample, and it's the right sort of variable, and the variable was close to 50%, then the error is plus or minus 3%. But all these other errors are not accounted for in that. Then we get non-response error. What about people who don't want to take part? They're busy, or people who are sceptical about answering the phone to us. And when people look back at the 2016 election in particular, they found that many Trump supporters don't want to speak to pollsters. And they don't want to speak to other people who ring them up or email them too, because they're very sceptical, they're very doubtful about who these people are. So we have a very systematic bias in the non-response error. And then we have adjustment error, because we never take the data simply as it's collected. We try to do some weighting, we try to do some adjustments to make it more realistic. In 2016, the weighting didn't take into account enough importance of not having college education, of being a white Christian, as being key drivers for a systematic change in the way people voted. One of the interesting errors in the 2020 election was most of the weighting assumed that Hispanics were one group, but they're not. And in fact, some groups, for example, those from Cuba, were much more likely to vote Trump than other Hispanic groups. So that particular adjustment was a flawed adjustment. So let's think about mapping the problems we get in general research to these solutions. Validity. Is asking people a direct question going to work? So if it is, how many children have you got? Yep, asking a direct question is likely to work. Do you cheat on your partner? Asking a direct question is not likely to work for those people who do cheat on their partner. So if asking direct questions doesn't work, then we can look at derived answers, or projective qualitative, or observations. We start to think about alternative ways of measuring it. What about measurement error? Did people make a mistake when they're entering their answers? You really want to try to avoid people typing in numbers, and you really want to avoid that people understand percentages. What percentage more would you be willing to pay is a question that people make a lot of errors in. So if you want to cut down on your errors, build some redundancy in, or some checks where you feed people's answer back to them. In the recent SMR pricing study, people said, okay, I'm going to spend this much to provide this survey. And we then fed back to them, so that is this much per group and this much per person. Is that what you meant? And some people said no and went back and corrected it. If it's qualitative, probe the consequences, because that will often tell you whether or not there's been a misunderstanding. Or collect examples, get people to take photos or to upload videos so that you can see the things they're talking about. Processing errors. Well, first of all, check for bad data, bad responses, errors in the data. Then you're going to recode the data quite a lot to make it more robust. A lot of people have found, for example, that coding agree strongly and agree into agree makes the data much more reliable, particularly when you start asking about top scores, because some people give top scores much more readily than other people do. So by grouping scores together, you can make your data more reliable and remove processing error. When we're doing qualitative projects, don't just read it and think that you understand it. Use proper analysis methods. Use grounded analysis or content analysis or conversation analysis or semiotic analysis to make sure that you're not making a processing error when you're doing qualitative research. Coverage error. Define the population. Is your relevant population the market, or is it customers, or is it regular customers? If you're using a panel, who are you missing? One of the issues that is being talked about a lot these days, particularly by Dave McCulkin, is the over 70s. So a lot of panels can give you people 60 plus or 65 plus, but they're often quite weak in the 75-year-olds, the 79-year-olds, who can be quite a distinct group. We talk about nationally representative, and now globally there are all sorts of working parties looking on the issue, because you know what? Those nationally representative samples tend to have the right age, they tend to have the right gender, They don't always have the right ethnicity. Nobody is looking to see what the disability statistics are, what the sexual orientation statistics are. We need to do better if you want to be nationally representative. If you're collecting that data online, who are you missing? If you're missing important people, you might want to do multi-mode research. Sampling error, this is the one that we've got nailed. We know what the sampling error is. We shouldn't think that it's the biggest error. Think about all those things I've just been talking about. If you've got a sample of 1,000 people, it's really unlikely that that plus or minus 3% is the biggest of the errors you're dealing with. It's much more likely that validity or coverage or non-response is going to give you a bigger problem than your sampling error. Non-response errors, we've got two key groups to think about. People who are asked to take part but who decline, and people who start but do not finish. This is where engagement comes into play. Can we make the invitation more attractive? Can we offer a better incentive? Can we make the survey or the qualitative exercise more engaging? Can we use gamification? Can we use chatbots to improve that process and cut down on the non-response error? And finally, adjustment error. Don't just report what you found. Work out what you need to do to make the data more robust, more reliable. We're going to code non-numeric data. So we've got text, we've got images. What are we going to do to turn that into codes which make sense? If we've got qualitative, we probably do want to turn it into text so that we can use text analytics as part of that process. So that's mapping problems to solutions. But now let's turn that around, and when somebody comes to us with a brand new solution, how do we work out which sort of problems we would use it for if we have that problem? So qual, we use that principally when the questions can't be asked in a way that generate numbers. Quant is actually really good when we know what the answers are. We just need to know how to count how frequently the answers are used, but we know what the answers are. If we don't know what the answers are, we're much more likely to use qual. And sometimes we don't even really know what the question is properly. So those are good situations where we're using qual. Gamification, where we're trying to reduce non-response errors. In some cases, we're also trying to improve the validity by making it a more realistic task. Multi-mode is about improving coverage, reducing coverage error, and also reducing non-response error. So we're giving people the invitation in a form that suits them rather than saying we want you to do it in this one specific way. Chatbots are about reducing non-response error and in some cases improving validity. So if the chatbot is branching intelligently to ask the right questions, that should improve the validity. But the principal use of chatbots is about reducing non-response error. Videos and images, reducing measurement error is one of the key things there, increasing the validity. So there are all sorts of questions we can't ask as questions. We can get much more valid data if we collect video, if we collect images. Conjoint is about increasing the validity. How important is it to you that your next holiday has this price, this number of nights, this number of swimming pools, this number of nightclubs, this number of restaurants? It's impossible for humans to define that. But actually, if we show you various options and ask you which ones would you pick and which ones would you not pick, you can do that task. So we can ask a much more valid task for some things with conjoint than we can with the direct task. So that is how we're mapping solutions to problems. And observational data increases validity in those cases where we can't ask direct questions. It can reduce the measurement error. So if we can automatically log how many times people exercise, that will be so much more accurate than asking them to keep a diary or just use their memory of how many times did they exercise in the previous month. So we can use observational data to increase validity, to reduce measurement error. So thank you very much for listening, and I look forward to your questions.